Let's take a look at all the interesting ways to do difference quotients. So we've shown how to do them in Excel, and you might have felt like, though, there's a lot of columns there. Can't I just collapse them into something like the tables in the book, just have an H column and a DQ column? And you can do that, but then you have a fairly complicated formula for the difference quotient. Doing it this way, each individual column is fairly simple, and you only have to type the cell formula that does the function evaluation once. And then once you have that done, you can copy it over here and it'll act on the new x plus h column automatically. So that saves a lot of time and trouble. You can do it in Desmos fairly straightforward. Here I'm just using square root as an example. It could be any function you want. And if you said x equals 2 in Desmos, Desmos is going to do interesting things because x means something special to Desmos. So it's better to use a letter that Desmos will not treat specially. So it could be A, it could be C. So that's one way to do it in Desmos. Another, and there you would have to change h and see what the new value of the difference quotient is, and maybe write that down. Another way to do this in Desmos and get the value of the difference quotient at different h values, you'd set your function value, some function formula here, you'd set some kind of central value, you'd define how to compute a difference quotient at any particular value of h, but not say h equals something in particular. And then you'd set up a table, and I'll show you how to do this in a sec, and say here's some h values, please compute d at those h values. So let's switch to Desmos. All right, here we are. I've got my function defined here. I've got my central value. I've defined how to compute the difference quotient at any particular h value. It's kind of interesting that it's graphing the difference quotient value as a function of h on the axis here. And now, instead of just hitting enter from here to get a new expression slot, I'm going to go up here to the plus and say add a table. And it defaults to calling this x, but I want to call it h. And here I want to say d at the h1 list. You can use any number you want to, but you have to use a number there as far as I know. You can't just use the letter h. And we can put in h values like -1, -0.1, -0.01, 0, 0.01, 0.1, and 1. And it will automatically take these h1 values, plug them into this difference quotient, and show you the values here. And it'll also plot them so you can see what's going on there. And if you zoom in enough, you can see that those two dots are separate. And that helps you kind of eyeball what value you think will go here. Remember, we're not, in chapter 1.1, we're not looking for exact computations of what should go there, just kind of intuition and eyeball estimates. Now let's go back and talk about how to do this algebraically. All right, I've switched examples here. Let's use 0.7x squared as our main function at x equals 3. Here's how we would write the difference quotient. And now we want to plug in the 3 plus h to the f of x function, and then plug in the 3. Plugging in the 3 isn't the hard part, but let's just imagine what we're going to do here. So we have a 0.7. Try writing this out before I write it out, just to train your brain that you really need to know this stuff. And then I'll do times 3 plus h squared, and then minus f of 3, so minus 0.7 times 3 squared all over h. And is that correct, or do I need to fix it up? You're probably thinking, he loves pointing out where the parentheses should go, and that's really what we need here. We really need those parentheses there. So f of x, whatever you give it, it squares it. If you give it 3 plus h, it will square 3 plus h. So we need to protect that with parentheses. So we need to point out this is not 0.7 times 3 squared plus h. This is not 0.7 times 3 plus h squared. And it's not 0.7 times 3 squared plus h squared. All right, so we really have to do it that way. It's also a good idea to protect this part with parentheses, because if it had another term to it, if it was 0.7x squared plus x, then we would have two terms here and we'd need the minus to apply to both of them. So doing it this way algebraically is leading us toward chapter 1.3, where we will be foiling all this out and simplifying. But here in chapter 1.1, don't simplify past this point. So don't FOIL it out. In chapter 1.1, wait till chapter 1.3, and by then you'll say, do I have to do another one of these? So don't burn yourself out in chapter 1.1. So what should you be doing in chapter 1.1? Tables and graphs and eyeballing.